Yeah, hopefully next year we can all just be in person and just not have to worry about any of these problems. So our second keynote and final presentation, Michael Hoffman. Michael is interested in predictive computational models, and he's interested in the genome, the epigenome, and the phenotype in human cancers. He brings together, as you can see from his many affiliations, he brings together sort of methods from machine learning and computer science into health applications. He is a CIHR new investigator and has received many awards. He's going to talk about reproducibility standards for machine learning in the life sciences. So thank you very much for your presentation, Michael.
Thank you very much, Rohan. Thanks for the invitation, and this has been a really exciting workshop the last few days. So I hope everyone, if you can, if you have access to the Zoom reactions feature, you might want to give Rohan a little round of applause. I'm going to do that because I think this has been amazing. Thank you so much, Rohan. All right, let's get started. Reproducibility standards. So first, some disclosures. I have a patent application related to machine learning, and NVIDIA gave me a GPU once. So machine learning is being used more and more in biology. This paper did a study of machine learning plus a bunch of terms that they think have to do with biology, and so the number of publications keep going up and up and up. I'm sure over the last year it went well over the 9,000 mark, went up even further. And as that happens, reproducibility becomes more of a concern. People being able to see, whether a machine learning study in biology is become more of a concern. So more recently, people have been starting to look at common problems in the reporting of machine learning studies in biology and looking at reporting guidelines. So here's one example of a reporting guideline called the DOME guidelines, Data Optimization Model Evaluation, which lists some key issues that need to be reported for a study to be really scrutinized by reviewers and editors. And it's one of several reporting guidelines that have come about for work in the machine learning in the biomedical space. So here are some tables from the Consort AI guidelines, which build on the previous Consort guidelines. Gets a little bit longer. And here's another guideline, which is the Spirit AI guidelines. There's even more parts up to the checklist, and the acronym gets even longer as well. It's more and more fun stuff to look at. So people may have come across the implementation of these sorts of guidelines and something like this sort of checklist. If you submit to any of the Nature journals, you now need to include a reporting summary, which includes whether you did all of these different kinds of statistics, and it also includes a section on software and code and data. And I'm going to give an example from a paper that Benjamin mentioned in the very first talk of this conference on Wednesday. So we're going to bookend it by looking at this very paper. So we'll zoom in on the software and code section for this paper. It's people following the Nature Research Reporting Guidelines, right? And they tell us, all the versions of the software they used in exquisite detail, right? They use DCMTK 3.6.1 _ 2016-0630, right? This is something that will really help you reproduce what they have been doing exactly, right? So all you need to do is get their code, and then oh no, right? So they tell us all that, and then they're like, actually, code, the release is not feasible. It's not feasible, and the data, most of the data is not publicly available. All right, so you look at this and it's like, oh, this is great. We're really pushing the boundary on reproducibility when we have guidelines that require people to describe their software versions in exquisite detail, and then allow them to say the code is not available just because we think it's too hard, right? And is it even fine? The authors in this case claim all experiments and implementation details are described in sufficient detail in the methods section to allow independent replication with non-proprietary libraries. Some of you may be familiar with the story of, Benjamin Habe-Keynes decided to look in to see whether this is actually possible, and it is not possible. There are a lot of, key details that are missing, right? So, it's not even really possible, I think, to see whether this is robust. You can't reproduce this in any way, right? You can't independently reproduce this training pipeline, despite this, what seems. I like Joel's analogy earlier this morning about how a paper without, a computational paper without code is kind of like a proof in mathematics a theorem without a proof, right? This sort of statement reminds me of what's called proof by intimidation, right? You just say it is easy to show that anyone can do this, right? And so if you can't do it and you don't have a lot of confidence, then maybe people will just assume that they're an idiot. This never works on me when I'm a reviewer. In fact, this is a magnet for me as a reviewer. When someone says something like, it's trivial to show that this, I'm like, no, you definitely need to explain that then in this case. So let's compare some of these reporting standards, right? So the three that I showed you before, DOME, Consort, and AI. DOME has 21 individual items that you need to report. Consort, the initial Consort reporting guideline had 37 items. When you add on the AI part to it, that's 14 items that have either been extended or added to. Spirit AI is even bigger. There were 51 items in the original guidelines, and now they're adding or extending 15 more. Right? What does this actually get you in terms of what you need to reproduce the study? So DOME, they do not require that you make data, model, or code available, but you do have to disclose if it's not available. So at least you'll know that it's not reproducible, and they recommend that people make it available, right? So the guideline doesn't require it, but they at least recommend it. The Consort AI, they don't even recommend any of these things, right? So they require you to disclose if the model or code isn't available. They don't even talk about data availability, right? So when they came up with this, they're just, I feel like on in a totally different section of the timeline for me, that making data available to independent researchers is just totally not something they were even thinking about. Right? Spirit AI is similar, but they at least require people to disclose non-availability. Right? So with these sorts of standards, how reproducible is stuff going to be? I'd say with DOME, if authors complying to DOME actually follow the recommendations and not just do the minimum, and you're lucky, you might be able to reproduce the work. For Consort AI, Spirit AI, it's possible, but there are no guarantees. And in reality, it's probably not going to happen for a lot of these cases. Like I think it's theoretically possible, but people are less likely to make their data, model, and code available, I think, if they come from a guideline like that. So how do we get here, right? Why did these statements, these guidelines, where did we get them from that they tend out to be, of so little use in terms of actually giving us reproducibility? Well, the key word is that they are consensus statements, right? And I think the latter two of those were arrived at something called the Delphi method. Something I was not familiar with 2 years ago, but even though it's very old, but somehow in the last year and a half or so, I've been asked to do countless of these Delphi panels on various subjects. And basically what it is an extremely fancy multi-round survey, right? So someone trying to come up with, technical experts to agree on something, will ask them a bunch of questions, or make statements that you're supposed to agree or disagree with on a Likert scale. And then, you'll go through multiple rounds of, if things got kind of some agreement, but didn't get, say, maybe 80% agree or strongly agree is a standard I saw once, then they'll, do a second round of the survey. And then maybe they'll do a third round of in-person or video conference meetings so people can hash out their difficulties. And there's some really nice advantages to this Delphi process, right? So one is that you can inform your guidelines by very large pools of experts. You can easily invite, more than 200 people to participate in your Delphi. You usually select a smaller group for the final meeting at the end, right? So you don't miss a lot of, say, corner cases or edge cases or something like that, right? And you also get some authority from saying, hey, we brought together, 200 of the world's experts in this field from all over the world, and this is what they agree with. All right, the disadvantages are severe though, right? So one thing, especially when you're talking about practices for researchers, what you're gonna get often is the least common denominator. I think there's also an element of regulatory capture when you have people writing guidelines and standards that they themselves will have to follow. Sometimes people become more interested in their what they think will benefit themselves rather than, what is necessarily good for science. And if you, set something up so that people have a super majority requirement for something to be included in one of these standards, then it's really hard to, overlook something like that. These are backward looking by nature, and it makes culture change very difficult for the above reasons, right? So, I mean, I've been involved in some of these, and I'm not supposed to, talk about the details of what happened, but, essentially sometimes I feel like people involved in this process question the very, the principles of what the consensus statement they're being asked to weigh in on is for their own benefit instead. So I think instead of looking at these complicated reporting standards, we should move instead to reproducibility standards, right? And I would say an ideal reproducibility standard should be more about functional, right? So some clear tests, can you reproduce this work or not? Should provide guarantees for readers, right? Not just a list of, check boxes and people say, well, I did this or I didn't do this, it's not very useful to say, you need to, you need to have a training test set split and not look at the test data, or you need to tell the readers that you looked at the test data and used that as part of, developing your parameters, right? Like doing that is just wrong, right? It doesn't give any guarantees to readers about the quality of the work if you can say, oh, here's a standard, but you don't have to meet it. You just have to disclose that you didn't do it. And finally, I think an ideal reproducibility standard should recognize a spectrum of ease of reproduction. I think Benjamin on Wednesday talked about several levels of reproducibility. I think we are starting with something. Our minimum level is kind of at its highest level, and we're going to move up from there. And so I'll tell you a little bit more. Casey Green got wind of some additional reporting standards in machine learning for biology, and this project was really his brainchild. He's like, we need to stop doing this bureaucratic stuff and do something that actually works. And an analogy we came up with is instead of just having one standard for reproducibility with 5 zillion different exceptions. You disclose this, that, or the other. We have different levels, like bronze, silver, and gold. And this is something we published in Nature Methods last year. You can read it for free, and it's very short. It's much shorter than any of those other standards that I talked to you about. So I highly recommend reading it. But I'm going to run you through some of the high points anyway here. So the bronze standard. This is the minimum standard, right? So the data needs to be published and downloadable, models need to be published and downloadable, code needs to be published and downloadable, right? Without these things, you're never going to reproduce the work, right? Maybe, if you're lucky and it's something very simple and the methods are described very clearly, maybe you can get away with just the data. But in most cases, you're going to need the code as well, at least. Let's talk about what sharing data means. So first, it means sharing the raw data. It doesn't mean sharing, some sort of ultra processed data that, is the very last thing that goes into your machine learning pipeline. It needs to include as many of the pre-processing, cleaning, et cetera, steps that go into this. What if you don't actually have any new data in your paper? What if it's pre-existing data? Well, you're not off the hook for helping other people reproduce the data part of your study there either. You need to include the information required to download and pre-process the data there as well, ideally in the form of a script, right? So when people in my lab, when they download data from various sources to start a project, usually they will put that in a script. They will put wget, whatever, or curl if you're a curl person, right? And that's how they record where they got the data from originally in a way that is reproducible. Now, we're getting to the point where in most other audiences, especially when I'm talking to biology and medical people, they're like, what about human patient data, right? What about human patient data? So first, I want to say that this is a standard that we need to have for most of the cases in biology where there's no human data involved at all, right? So it sometimes feels like people, use the necessity of exceptions sometimes for sensitive human data to kind of fight against the whole enterprise of data sharing altogether, which is quite something. But there's still ways to share private data, right? So one thing, you can make your data public, but there are definitely sensitive kinds of data where even de-identified data, you can't just stick it up on the web, right? Hold on. Okay. So one thing that you can do is you can do some sort of controlled access sharing. In genomics, there are repositories called like dbGaP run by NIH, which are for NIH oriented studies. And then in Europe, there's the European Genome Archive, or EGA, which is accessible for anyone in the world. You don't actually have to be in Europe, and you can upload your stuff to one of those centralized repositories, and it provides some sort of guarantee to everyone else that the data is out there, it exists. There's a process to get at it. The process part is often not quite as good as it should be. The guarantees aren't there yet, but I think things are getting better. But anyway, that's a way that people can make their data available that I think would satisfy this standard. There are other things that people can do as well. Both this and the slide in the last one are for this really excellent paper by Brian Bird and colleagues, which was a review on how to share human health data, right? In addition to the controlled access route, there are a variety of ways that you can post data that will help people reproduce your study or scrutinize it in more detail with minimal risks to privacy. So one, summarizing the data. So, not having any individual level of data at all. when you do these sorts of things, I really think it's better if you have controlled access, de-identify data, but also provide something like this to help other people scrutinize the work without having to go through the controlled access process, which can sometimes be quite lengthy. You can add a little noise sometimes to the data in a way that won't necessarily affect the results of an analysis, but can make it more difficult for people to attack the privacy of the data. You can redact sensitive parts of the data, and you can also generate a model that will generate synthetic data that is very similar to the initial data that at least someone will be able to test your pipeline on, right? So if someone wants to use their data on, use your method on another data set, right? It can often be very, very difficult to do that if you don't have any examples of good data, right? So this is a way of giving people essentially example good data. These are all good things. Where does the data go? So it's best to put them in specialist repositories, right? So if I have gene expression data, I send it to the Gene Expression Omnibus website, which is at NIH. A lot of journals in my field require that you either use GEO or the European equivalent. Less often, people are requiring microscopy data to go into something like the Bioimage Archive, and it's often because people don't know things like the Bioimage Archive exist. But these specialist repositories have, curators and infrastructure that ensure that there are quality checks, that appropriate metadata is collected, and so on and so forth. And it's way better than just dumping it up somewhere as a blob. You may be interested in a paper that my postdoc Sam Wilson and several other colleagues and I wrote, which is called Sharing Biological Data, Why, When, and How, which goes into great depth on lots and lots of different specialist repositories you can use for various kinds of data, which has become much more of a concern now that NIH is saying they're really going to require people to make things public. Sometimes specialized repositories don't work. Sometimes there's not really a specialist repository for the data. So there are generalist repositories. I use Zenodo a lot. I love it. It's free. It's run by CERN. If it's over 50 gigabytes, you can often negotiate that with Zenodo. If not, Dryad will be happy to take your money to make your data available. And finally, it's never like, this is never satisfied by putting the data up where it's under 100% author control, right? It's not on the lab website. It's not on GitHub, not under some random S3 bucket, because that does not provide any of the guarantees that we need about provenance, about whether stuff will stay around, whether stuff can be changed later, that sort of thing. It's just, it's, I think, as appropriate as just putting all your papers up on GitHub and not even putting them on a preprint server. You need something more. Okay, sharing models. What is people are like, what do you mean by model? So model, I mean the structure and the hyperparameters and trained parameters, or similar sorts of things for whatever kind of machine learning you are doing. But really I see it as the output of the training step, if you have a training step in your procedure. Theoretically, you could often reproduce the model just from the data or code. In reality, this is sometimes quite difficult, and including the model as well, I think provides a huge acceleration in people being able to look more deeply into your study or to reproduce it or extend it. I will say that if you do a big hyperparameter sweep and you generate hundreds of thousands of temporary models, you don't need to include all of those, right? It's only the model you use to make final predictions somewhere in your paper that you really need to include. Where do the models go? We have a similar sort of thing. In machine learning and biology, we're starting to get more and more specialist repositories just for machine learning models like Kipoi and Sephora. If not, you can put it up on Zenodo. Never under 100% author control, right? Got to put it up somewhere that will give you a DOI or something similar. Sharing code. I think I'm really probably kind of preaching to the choir here on sharing code. I would just say, treat papers without code with skepticism as papers without methods text, because the methods text for complex computational analysis is almost never going to be enough to reproduce. And that's not because the authors are intentionally hiding things back. It's just because it's really hard to get all of those details. A lot of them are embedded right in the code. Where does the code go? Zenodo. I bet you guys can all guess what's coming up next, right? Not on the lab website or GitHub or something. People are like, but I like GitHub. Okay, using Zenodo and GitHub is great, right? You get the guarantee of persistence and the provenance and the tracking and all that from Zenodo, and GitHub is much more convenient for people to further develop the software and use. But you should snapshot your code at the time of any publication at least and put it on Zenodo. So does anyone think, with the bronze standard, are we actually going to be able to reproduce someone's stuff? Oftentimes it will still be quite hard, right? So I say it's the minimum standard. I feel like the bronze standard is often going to be the minimum standard to which the person who did the analysis originally would be able to reproduce it if they were taken out of their lab and plunked down on another lab on the other side of the continent, right? Because there's some tacit knowledge that they might have that other people are gonna miss. They have some nice things about the environment of their current workstation or server, and when they go to the other side of the country, suddenly they find the software they need isn't installed or whatever. So the silver standard requires everything in the bronze standard, but some other things to really make it much more likely that you'll be able to reproduce the work independently and make it much more smooth. And so one thing we talk about in the paper is that reproducibility is really a spectrum that I would measure as the time and effort it takes to reproduce the study, right? And it's really not, you can do this. Well, sometimes it's really you can't do it, right? So it might be forever in the case where someone doesn't provide any data or code, right? But there are definitely degrees of how easy it is if someone dumps all their code on Zenodo versus tells you which order you need to run the code in. Right, so dependencies are super fun. It often feels like playing Wordle if dependencies are not clearly specified, right? And even when you have something like that lovely nature reporting checklist with all of the versions earlier, it is super, super tedious to install the right versions just from that sort of description. So it really, to get the silver standard, you need to be able to install all the dependencies with a single command. Package manager of your choice. There are a lot of good things about Conda. Also, a lot of people hate Conda, but there are multiple ways to skin this cat. Container systems, Docker is the best known one of these, are also a good way to do this, right? Docker can be a really good way to create an environment that you can, spin up reproducibly somewhere else. I do have two concerns about Docker. One is that sometimes I've seen people using Docker and they end up with code that can only ever be run within that sort of Docker, that particular Docker image. It gets really dependent on a extremely particular setup of the system, and that makes it brittle and actually harder to reuse. The other thing is that Docker is not actually a panacea for these sorts of things. I have, in the last month, we've had code that was identical code running in our test suite in an identical Docker image that suddenly started spitting out different results. I don't know. We don't know why that is. If it's changes in the host OS, changes in the host CPU, things like that, but it's also not 100% a panacea. All right, analysis details. In what order are the components used, right? It's great to give people a bunch of scripts, but it's really hard to know where to start. There's several ways to do it. You can have a detailed README. You can put numbers before scripts, right? You can like one underscore preprocess.sh, 2 underscore train.sh, 3 underscore, inference.sh, that kind of thing. You can make things really nice for people and, create some sort of script that runs everything all at once. It's also really helpful for people to know how long did this take, right? Because if they're going to try to reproduce it, it makes a big difference to know if it runs on someone's laptop in an hour, or if you need 1,000 CPU cores to run for 24 hours. And finally, going along with that, what sort of system resources, I guess required is not really the right word. It's more of a reporting thing, right? What did you use that will help people decide, how long they should expect it to run themselves. Another thing we need to consider for the silver standard is the challenge of randomness. You need to save seeds used for pseudo-random number generators. Unfortunately, there's sometimes more pseudo-random number generators being used than people realize. Sometimes there are more places to set seeds than people realize. Also, this is something that is sometimes not prioritized by certain libraries that prioritize speed over determinism. Sometimes there are options for non-deterministic operation. I think this is an area of increasing development. And finally, again, publishing the trained models can make a very good backstop against some of the challenges of randomness, which is another reason why we require it as part of the bronze standard. Okay, so the gold standard, this is really the stretch goal, right? So it's the silver standard plus you can reproduce the entire analysis with a single command, right? Wouldn't this be the dream? I mean, some people are already doing stuff like this, right? Some people have been doing stuff like this for years and essentially don't get any sort of recognition for it. And I would be cautious to say that the gold standard should be, required by any journals or funding agencies tomorrow or something. But if people are doing all the work to make something like this possible, I really think we should recognize them for it. The gold standard, raises some problems with compute-intensive analyses. If you use workflow management software, that helps. Also, storing and publishing intermediate results enables partial reproduction, where you can do things like, maybe some part of the analysis process takes 1,000 CPU hours and the rest of it takes 2 hours. Well, if you could take the intermediate results from the 1,000-hour part and publish that as part of your package and include that in your single command, then you can kind of get around this. And if people really want to reproduce that part, they can delete those files, and the workflow management software like SnakeMake should be, the system should be designed to so that people can automatically reproduce those intermediate files, assuming they have the 1,000 CPU hours they need. So here's a table with all of the reproducibility standards. Again, they're in the paper. Most important really are the first 3 though. The data have to be published. The models have to be published, the source code have to be published. All right, let's look at how our reproducibility standards compare to the reporting standards, right? So we require data, model, we require code. As you go up the ladder, the code, we require more and more from the code essentially. And instead of just, if you're lucky, there is essentially a guarantee that you will be able to reproduce this with a certain amount of effort. So this is all great, right? I'm sure I said again, I was preaching to the choir. I'm sure everyone here loves this, but how do we make, how do we get people to do this, right? How do we make reproducibility a priority? And for this, I would like to, wake you guys up. Let's have a little poll, right? Which is the most important aspect of evaluating research output? Is it quality, quantity, or popularity? Are people seeing the poll? I'm not saying, oh, there we go. Okay, people are starting to answer the poll. All right. When people keep entering more and more and more, but when it slows down, I will end things. So get your votes in now. 3, 2, 1. Poll is over. Okay, so you know, 21 out of 29. Yeah, sorry. So 90% of people say quality, right? 5% of people say quantity. 5% of people say popularity. I'd like to talk to that person, know whether they're serious or they're just trolling me because of my loaded survey design. But yeah, we can talk later if you want to identify yourself in the chat. It's anonymous. So, you know, it's interesting that people generally, whoever you ask this question to, right? In my opinion, if you ask it, especially if you ask it this way, people are almost always going to say quality, right? What do we look at when we evaluate output of researchers, right? Sometimes we look at quantity, we look at number of publications, we look at size of publications, right? Often we look at things that are really, you know, popularity, right? People like to talk about these things as impact. They are, let's say, very imperfect proxies for impact. You know, people can look at number of citations, you know, number of citations, and you know, that's one way of seeing how much this has an effect in the literature. What's most often used, I find, is number of citations to other papers in the same journal, right? Which I think in the year 2022 is kind of bonkers, because we have the data on the number of citations of the actual paper, which to me is kind of a dubious enough proxy, and people want to make an even further proxy to look at it. And then we have things, alt metrics that people keep talking about more, like number of downloads, number of tweets, number of media mentions, maybe media mentions. As someone with I have more than 20,000 Twitter followers, and I will say that I think judging research output by number of tweets is like not a good idea at all. I really like, I think if we start doing that, the system will be gamed in a way people really don't like, right? But everyone wants to talk about quality. How do you measure quality, right? No one, you know, people don't really know how to measure quality. Sometimes people talk about papers being in particular journals in my field being of higher quality, and I don't really buy that particularly, because really what the journal editors are often looking for is, you know, whether something will have more impact in their words or popularity in mine, right? And for a lot of journals, if you get the same reviewers, you're going to get similar reviews, and people are going to ask for similar sorts of, you know, stats, soundness of research, et cetera, et cetera. I think the overemphasis on popularity, people have started to recognize that it is a problem more and more. And one outcome of this has been the San Francisco Declaration of Research Assessment, or DORA, which is a enterprise endorsed by many funding agencies and institutions and some scientific societies, where they're trying to promote the value of scholarly outputs that aren't just journal articles, and trying to reduce the destructive effects of chasing journal impact factor, focus more on rigor and reproducibility, open science practices, et cetera, babies and apple pie, all sorts of nice stuff, right? So an increasing number of organizations are endorsing DORA, right? So here are some organizations here in Canada that have officially endorsed DORA. All of the the biggest government funding agencies, the biggest research institutes in Toronto, associations like Canadian Association of Research Libraries, and so on and so forth. And it's, again, great that they've endorsed this, but how do you actually put this into practice? I've been involved in some discussions and two different committees for my sins at my institution on how do we actually implement DORA now that we've signed it. And here's some things that I've learned from that process. Institutions evaluate research. Researchers, they evaluate at hiring, at an annual review, There's, periodically, sometimes a deep review every few years, or promotion review, tenure review, that sort of thing. And institutions almost also want an idea of how, they are doing as an organization, how individual organizations within them, like, colleges, departments, or whatever, are also doing. And I'm going to focus on the researcher side of the puzzle today, but we can talk more about the other stuff whenever you want. I will first say that doing the same thing over and over again and expecting different results is profoundly silly. And in this case, that means that, the people who are actually doing the reviewing back here, because it's usually people, whether they are overworked department chairs or overworked deans or overworked members of promotion and tenure committees, and you give them a CV that is full of article names and journal titles, right? And say, tell me whether this person is good enough or not, or whether they deserve to get a raise, or, whether they should be hired, something like that, right? Even if you tell them, oh, by the way, we're not supposed to use journal impact factor anymore, you're supposed to actually look at the work, right? Like, can you imagine, my director who has 65 faculty reporting to him, right? Like him reading, 65 times 3 papers every year at annual evaluation time, not going to happen, right? So, but I feel like the journal-centric approach is unacceptable. Lots of people have realized this. There's been lots of research showing the, bad effects of it. So what are some other things we can do? So one thing is you can ask the researchers to articulate the advantages of their research themselves, right? So there was some chat, and I haven't been able to read all of the chat, but there's some chat about, hey, some stuff other than research quality is important. If your stuff gets disseminated and makes it into the field in various ways, that's really important. I agree entirely, right? And that's something you aren't going to see from journal impact factor. It is something you can see if you ask the researcher, what's the impact of your work? And you say, my work, went into deciding the new guidelines for this, that, and the other that are followed by, the, Health Canada, like super important, right? And the researcher says, what the quality is. Did the work meet any formal standards, right? This is where the bronze, silver, gold thing comes in. The researcher can start saying, we met the DOME standard, and we met the bronze, standard for reproducibility in the Heil et al. Paper. Another thing you can ask is, were there data and materials reused by others? Are they just, producing papers, or are they producing other artifacts that other people can use? And if so, what are some examples of, say, other papers where people have used their data and materials, right? That's really where the rubber meets the road. If you can show that, yes, these people who we aren't collaborating with, we aren't co-authors on their paper, I don't think that counts, have used our data, or they've used our software to do this amazing thing, which, it has a lot of impact, and so on. These are things that institutions can look at. These are things that that funding agencies can look at as well, right? So here's an example from the Alex's Lemonade Stand Foundation, which, despite the cute name, is a major funder of childhood cancer research. Started, they got sick of people hoarding data on, from childhood cancer studies, and started saying, this is something you have to address, that will be addressed competitively in your grant applications. This is something that I think needs to be done more and more. People need to say, why are they, what are they going to do to ensure that their research isn't just publications, but that the outputs are used, that it's not wasted. What is their track record of doing that in the past? These are all great things. I see more and more funding agencies are starting to put requirements on data sharing. Like NIH has the new data management sharing policy, but peer reviews are forbidden from including their look at that in their scoring of an application, which to me, again, is bananas. Because if someone is creating a data resource and they have a good plan for sharing it, that is significantly going to change the significance of the grant. I pressed the wrong button. I'm so sorry. Give me 1 second and we will get right. I will start my screen sharing again. Well, I pressed the escape key when I was in a different window than I thought I was, and PowerPoint very helpfully immediately quit what I was doing. So thank you very much, PowerPoint. Okay, I'm going to end here with a call to action. I think we have some time for discussion afterwards. So if you have questions, get them ready. If you have comments, get them ready. If you hate everything I'm saying, get them ready. But if you agree with the sort of things I've been talking about, here are my recommendations for you. Here's what you can do to make the world a better place. So first, sign Dora. Go to sfdora.org. It seems like a small thing, but it is not, because I have seen both at my institution and at other institutions that we've been looking at for, examples of how to deal with, having signed Dora, what a huge difference it makes to make a public statement that you are going to start considering research quality rather than journal titles exclusively, right? It's possible that some institutions will claim that they're doing that and not actually doing things, but I think in a lot of cases it's something that kicks off a lot of contemplation. At my own institution, they're contemplating how can we evaluate more research quality? How can we evaluate more people's whether people's work is reproducible, reusable, et cetera, et cetera. Your own research. I'm not going to tell everyone that what you need to do is go out and accomplish the gold standard for all of your other papers from now on, right? You don't have to do that. What I would like to, so the other day, I was in a discussion with some people and they were like talking about, really, it's really hard to do data sharing right? Because you have to be really careful about this and that and the other, and having the right metadata and describing this and blah, blah, blah. And, it's so hard and that maybe people shouldn't be required to do it. And I'm like, if it's too hard to do it right, try doing it wrong. I think I believe that, most scientists want to do stuff like this. They want to do it well, and that they can start by taking little baby steps, right? You can start by, publishing your data, just dumping things on Zenodo deposit, right? Then as you learn more, as time goes on, you might learn better ways to organize your data. You might learn better ways to have organized your data from the start of the project so that what happens at the end is less painful. If people are actually reusing your data, if you don't do it well, it's mainly going to be a problem for yourself as people keep asking you for help, or if people are evaluating your research later and find that it's not up to snuff. But just start, learn more, do a little bit more each time. And finally, I think people should be signaling that reproducibility practices are important. When you're reviewing a paper, compare it against the standard. Say, this paper didn't meet the bronze standard, and I will tell you, if anything doesn't meet the bronze standard, I'm definitely going to recommend rejection to an editor, right? I really feel like that's the bare minimum. It's amazing that in this year we still have reporting standards that don't require stuff like that, because to me, this has been something that should have been required for years and years, and that lots of people have been doing. If you're reviewing grants, look for a commitment to data sharing. Look for a track record of data sharing, code sharing, that sort of thing, right? Like if someone says they're gonna, share their code, and you find on their website and their previous papers there are no examples of sharing code, well, that's something that's definitely going to go into my reviewer comments, and it's definitely going to affect my assessment of the significance of the grant, if not other things. Hiring. If you are hiring people or involved in hiring, ask for code as part of the process. You need to signal to people that that's something that you're interested in. So when people apply for a postdoc in my lab, they have to provide one representative code sample, right? So usually like a GitHub link, and I can look and see, you know, do they have some sort of minimum standard of coding ability? I'm not looking for superstar programmers necessarily, but you know, do they do this at all? And this is something when people think that, you know, the only thing that is important in hiring is journal titles, they're going to focus a lot on that and not on sort of reproducibility. And so all of these things, do for yourself. Also advocate for your institution to do them. Advocate for your institution to sign DORA, your department, your college, your university, right? You know, if you're involved in a journal editorial board, start saying, you know, we should require the bronze standard. You know, that sort of thing. Okay, that is all I have to say today. Thank you very much, and I look forward to any of your questions or comments.
Thank you very much, Michael. Really appreciate your talk. Ben, and if anyone else has any other comments, please just raise your hand and I'll call on you. But Ben.
I mean, you're literally one office away, but I'll use that opportunity to ask you a question. I know we've had some discussion in the past, and I would like to hear your opinion here. Is it better to share kind of rough, sometimes partial, incomplete, undocumented materials with your publication, or nothing? Because I really think that people think that it has to be really high quality or perfect to be shared with the community. So what's your opinion on that?
No, my opinion is share what you've got, right? Like you know, as Benjamin knows, Benjamin has called me a perfectionist because I am, right? And you know, I think a lot of people in academia are, but like you aren't going to have the time to fix your code later after you publish it. It's just, you know, in most cases it's not going to happen. And there, even if someone, you know, even if you can't meet the gold standard or the silver standard, and someone can't sit down and press a button and re-execute your code tomorrow, or even get it to work at all ever, there's still a lot of benefits to having it out there, because people can see what you did, right? People can scrutinize, you know, how it is your data got transformed from this to this, right? They can see why did it not match what they expected from reading the method section, right? And often that's because of ambiguities of the English language as compared to computer code. So even if your code doesn't work, I say upload it. It is going to help people understand it. It's going to help people, you know, go to the next round of science.
And I would say, even if it takes a bit of bandwidth, if you get a lot of comments, questions from the community, be proud about it. It means that your publication generated some excitement, right? And I think in those cases, I'm always eager to kind of correct the code, make it better. On the other hand, I don't want people to just share partial, incomplete code just for the sake of probing the community neither, right? There must be a balance. But I'm always very excited when I receive questions about a code that's supposed to run but does not. Right?
Yeah, I had a software package that was really hard to install. This, like that previous talk, a lot of this is, you know, informed by my own past mistakes, and you know, would periodically get mailing list emails about, I can't install this, what's going on, right? And then, you know, after a lot of effort, we made it much easier to install, and our mailing list traffic dropped. And I'm like, oh no, is anyone still using the software? Anyway, people were. It was really nice to run into people at conferences and be like, oh yeah, I used your software, instead of like, oh yeah, I tried your software and I couldn't get it to work.
Kevin?
Yeah, thank you so much. This is a great talk. I actually have many questions, but I shall limit myself to a reasonable number. One question I had for you was just a simple technical one, which is that you're often dealing with large data sets. And the thing that I run into is actually that Git is really great for code sharing, and code sharing on teams, very difficult for data sharing amongst teams. And you were talking especially about intermediate outputs being a thing that you want to store and share amongst your teams and coordinate on. And that's really hard to do when like those outputs are like gigabytes large and Git's like, nope, not doing that. So I was curious, my first question is simply, do you have good recommendations for tools on that specific point? Because that would really help my work.
Yeah, I'm not on mute, right? Yeah, so first, I mean, my recommendation first for this sort of thing is to look at Zenodo. And I have a lab sort of, you know, checklist or guidelines for how to upload things to Zenodo. And basically you can just upload a zip file that has, I think, up to 50 gigabytes worth of stuff in it. And that's how I would share this sort of thing. You know, I'm assuming that your intermediate files aren't going to change or need the same level of tracking that you do for source code. I think this is, to me, this is something that you are only going to do at either publication time or, you know, some other sort of major milestones, and it should be relatively easy to make a zip file and upload it.
Well, the specific thing occurs for us is that we actually have multiple analysts working on things across different institutions. And so there's actually a need to share intermediate files amongst those analysts where like person one can do, and this especially shows up when like you have different data use agreements with people. Like I'm the one who can do health data. I'm the one who can do, you know, IRS data. I'm the one who can do this. And so you're shipping these files amongst each other. And, and it'd be nice if there were like a way to do that consistently and in a way that's tracked and things like this. And that's what, so there are other times when it occurs. So, but I
assume you're familiar with get large file storage.
Yes,
that's the, you know, like I'm really focused here on sort of, you know, external reproducibility, and it sounds like you have some very different sort of challenges than we do, where, you know, in my field where usually the data ends up in one place before people start working on it. But yeah, that's what I can suggest for you. Maybe other people have ideas they can put in the chat.
And the second thing that I had was that I was curious as to kind of what Ben was indicating. I will put code on the internet and I have reviewed it, but there's no peer review process. There's no code review process as part of the peer review process for things. And so I would love it if somebody would look at my code and make sure that it actually does what I say it does. But there's no formal way to do that right now with external reviewers of code as part of the process. And I'm curious as to how you approach that in your lab for like, do you have somebody red team your code or somebody external review your code or before actually publishing?
No, we do not do that generally. We have some pre-existing, like not before publishing. Actually, we do it after publishing. So stuff that is, you know, already been published that we are continuing to develop, we will usually do that through a you know, pull request and code review model. One thing that we talk about in the machine learning reproducibility standards paper is the idea of a reproducibility author. So this is something where you know, someone at a totally different environment, institution, et cetera, gets the job of essentially just trying to reproduce the work from what's in the paper, right? It kind of reminded me a little bit of Stephen Eglin's code check from a few days ago, right? Where you try to do an independent replication of things, except, you know, in the way we envision it, it's something that you do, you know, even maybe before you put the manuscript up, and the credit for the person who does it is being part of the authorship team. I think that usually this process is going to involve a lot of back and forth, and, you know, to actually make it reproducible, and a lot of intellectual input from that sort of author. And that's one way that, you know, we can propose to make this sort of thing possible, because otherwise, you know, there don't really seem to be a lot of people interested in just, going out and testing other people's random code on the internet.
Kevin, you're done? No other questions? Does anyone else have any other comments or questions?
I know there was a lot of stuff in the chat I didn't keep up with. So if anyone wants to re-raise any of this stuff, please feel free to tweet at me.
Yeah, Jake, did you want to add some?
Sure, this was inspiring, and I agree. I love your calls to action. I might add to your calls that I think that people do better quality work even on their own if they think that they're collaborating with themselves in the future. Like you can not care about ethics or science or all the things that I actually think you should care about, and you should still work in a reproducible way because there's somebody else who is you who will forget what you did, or someone will come back and ask you questions. So that's just like it's like the least important kind of an argument, but I've definitely had very goal-oriented, friends who say, look, the only thing that matters is if I get publications, nothing else matters. And I say, well, you will get publications better if you work in these particular ways because this is for yourself, even if you have in a very self-interested way. Anyway, a small point, really.
No, I agree with that entirely. I mean, this is a point that we make in the, biological data sharing with the, with the photo of the toddlers playing together, is that, for data sharing in particular, I feel like one of the biggest and, universal benefits of doing it properly is that once it's done, it's someone else's problem to take care of your data, right? You don't have to store an old hard drive somewhere and, worry about whether it will break someday. It will, or keep paying for a, space on a network service or an S3 bucket or something. You've just offloaded a problem. And to me, like when I need to go back and look at the data or code of any of my past papers, I usually just look at the public sources. They're there, they're well organized, they're better organized than whatever wacky structure we used on our file system. And it's just so easy. So I agree entirely. People need to understand that better.
Any other questions or comments for Michael? Oh, we'll just say thank you very much, Michael, for your presentation. Very much appreciate the keynote. It's just wonderful.
Thank you.